Okay, so simultaneous equations. Basically, we have two equations. Equation 1, 5x plus 3y is equal to 41. Equation 2, 2x plus 3y is equal to 20. Now, either of these two equations, if they were just on their own, we would not be able to solve them because we have two variables, two unknown values. But because we've got both of them, because we've got two of them, we may be able to solve it. Okay, simultaneous just means at the same time. We are going to solve these two equations at the same time. So the way that we're going to do it is we're going to subtract them. And the reason why I'm going to subtract one equation from the other is because when I do that, the 3y will cancel out with the 3y. The x's won't cancel out, but the y's will. So what we're going to do is going to subtract equation 2 from equation 1, because then the 5x take away 2x will be 3x, 41 take away 20 will be 21. And I can actually do probably the rest of this equation in my head and work out what x is. But I'm going to go through the stages here. So we're doing equation 1, take away equation 2. So we've got, well, we can do this by just look, and what I'll do is I'll write it all out. So I'll do 5x plus 3y. Then I'll do take away equation. I'm just doing the left-hand side to start off with. So in brackets, 2x plus 3y. And that's going to be equal to 41 take away 20, 41 take away 20. Okay, so that's my way of combining the two equations. I'm taking equation 2. Sorry, I'll take an equation. Hang on a second. I'm taking equation 2 from equation 1. Yes, good. Okay, so basically this brackets can open out. So you've got 5x plus 3y, take away 2x, and the plus 3y becomes negative 3y. And on the right hand side, you can just say that's 21. So let's collect the variables, collect the terms, I should say. 5x minus 3x minus 2x is equal to 3x. You got plus 3y minus 3y, so they would cancel out, which is why I chose to do this method. Is equal to 21. And then from here, I can divide both sides by 3. So I can say x is equal to 7. So now I've got a solution, or part of the solution, done. By combining the two equations, I worked out that x is equal to 7. So what do I do next to find out y? I just plug it back into one of these equations. Which one would be that would make most sense? I don't think there's much difference really. Maybe equation 2, because 2 times 7 is slightly easier than 5 times 7. So let's do equation 2. I'm going to also rearrange this actually. So I'm going to take away 2x from both sides. I've got 3y is equal to 20 minus 2x. And then I'm going to divide both sides by 3. So I've got y is equal to 20 minus 2x divided by 3. So now I've got a rearranged equation where y is the subject. So that's going to equal to 20 minus, and we know x is 7, so 20 minus 14 divided by 3. 20 minus 14 is 6, and divided up by 3 is 2. So we have x is equal to 7, y is equal to 2. We can check that out by maybe plugging into the other equation. So 5 times x, 5 times 7 is 35, plus 3 times 2, which is 6. And that does in fact equal 41. So looks like we've got that right. So the answer is 7 for x and 2 for y. These are, by the way, linear simultaneous equations. Basically, if an equation is linear, it means all the powers are 1. So x to the power of 1, y to the power of 1. All the powers of the variables are 1. Okay. If that's not the case, then it is not a linear simultaneous equation, and they're a bit more tricky. So I won't do that in this video. I won't do that today. We might do it in a later lesson. But what I do want to do in this video is show when we wouldn't solve it in quite the same way. So let's find one that we wouldn't solve in quite the same way. This one, that's equation 2, question 2. I wouldn't take them away this time. What I would do is add them, because if I added them, then the plus y and the minus y cancel out. The first step is always to try to cancel something out, so you end up with an equation with only one variable, like here. Before we took them away, because they're both positive 3y, but here I'm going to add them, because when you add y to negative y, you get just nothing again, so it cancels out. So let's just solve this one now. Or if you're watching this video, you can just pause it and then try and solve it, and then you can play it and see how I solve it. So we're going to add them, equation 1, and this time it doesn't really actually matter which way you add them, of course, because 1 plus 2 is the same as 2 plus 1. This time what I'm going to do, I'm just going to add the terms straight away. So, and I could have done that before, I could have taken away the terms straight away. So 5 plus 3x is just 8x, plus y minus y is just nothing, and then 11 plus 9 is 20. So that means x is going to be equal to 2.5, right? 20 divided by 8 is 2.5. You can do that, the quick way to do that in your head, 20 divided by 4 would be 5, and we need to divide it by 2 after that, because that would, if you divide both sides by 4, that would give you 2x is equal to 5, so therefore x is equal to 2.5. So that's our solution for x, and what do? We put that into our equation for y. I would use equation 1 this time, because all I have to do to rearrange it for y is take away 5x. So y is equal to 11 minus 5x, which in this case is going to be 11 minus 5 times 2.5. What's 5 times 2.5? Correct. Mm-hmm. Correct. 12.5. So y would be equal to 5 times 2.5, which is 12.5. And if we do 11 minus that, we actually get y ends up being a negative number, so it's going to be negative 1.5. So we can put those values in to check. Let's try them into equation 2. We don't. The checking isn't necessary. It's only if you feel like you rushed it and think, oh, did I make a mistake there? You can always check. Mm-hmm. So 3. Let's do so 3 times x, 3 times 2.5, which is 7.5. Minus, and don't forget when you minus a negative number, that's the same as adding it, adding a positive number. So I'll just write it like that first. So that's the same as 7.5 plus 1.5, which does in fact give us 9. So yeah, that's good. So I'm going to show you one more type of example. So we took them away and then we added them. We're going to do another type of question where it gets a little bit more complicated. So we're going to find it. We've got some wordy questions there. We're not going to bother looking at those at the moment. What I'm interested in is this one. This one looks good. So maybe I won't actually, maybe I'll just say here, what would we do? What would be the process? Well, we can't just add or take away because nothing will cancel out. So what we would do first is we take this equation. So let's just number the equations. Let's say that's equation 1, that's equation 2. We take equation 2 and we first multiply it by 4. Because if that is equal to 4, then 4 times this is equal to 4 times that. So equation 2 times 4 would end up becoming, and you just multiply each term by 4, 12x minus 4y is equal to 4 times 4, which is 16. So, and why did I do that? Because I've got a 4y here and I've got a 4y there. This is a negative 4y, this is a positive 4y, so now I will add them. So I'm going to do, let's put this in square brackets so we don't think this is part of the equation. So I am going to take that and I'm going to add it to equation 1. Okay, so 2 times 4 we know is this one here. Oh, wait a second. No, I don't really want to do it that way, do I? I want to just add the terms first. So 12x plus, and make sure this is, a classic mistake here is that people get confused which they're adding. So if you've got highlighters, it's quite good to do this here. So I'm adding this one, which is all of this. I'm adding it to this one, not this one, but this one at the top here. Okay. So you're less likely to make a mistake then, hopefully. Or you could just cross out the one that we, I don't know, think about a way to make it easier. So 12x plus 2x, which is 14x. And then we're going to, we've got minus 4y plus 4y, so the y's are going to cancel. So that becomes nothing. And then we've got 16 plus 26, so that's going to be 42. So we divide both sides by 14. Well, I know 42 is in the 7 times table, so this should give us a whole number. Yeah, 3. There's our answer for x. What would I do from here? I could plug them into this equation or that equation or this equation to find out the final answer. I think I will use equation 2, rearrange it. So I would first add y to both sides. That would give me 3x equal to 4 plus y. And then I would take away 4 from both sides. So y is equal to 3x minus 4. 3x is 9, minus 4 is 5. Okay. So we won't bother with a check this time, but that is basically the different. There is one other level, and that is this one here. And in this case, we would have to multiply the top equation by. Well, we got a choice actually. If we want to cancel out the y's, I would multiply the top equation by 3, and multiply the bottom equation by 2, and then we'd end with 6y and 6y, and then we'd add them because they'd be positive and negative. But you could also do the other way around and cancel out the x's. Yeah. So that's simultaneous equations. As I said, you can do it with non-linear simultaneous equations. It gets a bit more tricky, but that's a starter, linear simultaneous equations.